The diagram above shows a sketch of the curve with the parametric equations x equals 2 cos 2t and y equals 6 sin t, where t is between 0 and pi over 2. Part A, find the gradient of the curve at the point where t is pi over 3. So, gradient, we want to find the gradient function, so dy by dx, and I know that dy by dx is equal to dy by dt divided by dx by dt. So I want to differentiate my x function and my y function with respect to t. So let's start off with the x function. Cos differentiates to be minus sine, so I get minus 2 sine 2t, but by the chain rule I need to multiply by the derivative of the inside. So multiplying by 2 will actually make this be 4. So that's my dx by dt. Now to find dy by dt, 6 sine t differentiated will become 6 cos t. So I can then substitute those into my gradient function. So my dy by dt divided by my dx by dt. I can simplify this a little bit. The 6 divided by the minus 4 is minus 3 over 2. The sine 2t here, I know that's the same thing as 2 sine t cos t. And that's quite useful to do because the cos cancels out. The 2 times the 2 gives a 4. And so this is going to simplify to be minus 3 over 4 sine t. I want to know the gradient when t is pi over 3. So let's substitute the pi over 3 in here now. So minus 3 over 4 sine pi over 3, which gives us my answer, minus root 3 over 2. So that is the gradient of the curve when t is pi over 3. Part B, find the Cartesian equation of the curve in the form y equals f of x, where x is between minus k and k, and I need to state the value of the constant k. So, I am going to need to link these two equations together to get y as a function of x. The way I'm going to do this is that I'm going to rewrite the cos 2t. I know the cos double angle formulae. I know that cos 2t is either 2 cos squared t minus 1 or cos squared t minus sine squared t, or the one I'm actually going to go for is 1 minus 2 sine squared t. The reason I'm going to go for this version is because it has the sine squared t here, which will help me link it with my y function because y has got a sine in there. So, let me replace the cos 2t with this. So I can say that x is equal to 2 lots of 1 minus 2 sine squared t, which I will expand the brackets now. So 2 minus 4 sine squared t. Let's now look at the y function here, and I'm going to rearrange this to make sine the subject. So I'm going to say that sine t is equal to y over 6, which I can now substitute in instead of the sine here. So I'd get x is equal to 2 minus 4 lots of the y over 6 squared. This is my sine t squared. Right, let's tidy this up. So I'll have 4y squared over 36. The 4 over 36 will simplify to be 1/9. I'm going to multiply through by 9 here to simplify this further. So 9x is equal to 18 minus y squared. I do want to make y the subject. So let's move the y squared over to the left-hand side and the 9x to the right-hand side, and then square root to get that y is the square root of 18 minus 9x. So that is the Cartesian equation of the curve. I need to think about the domain though. What values of x can be taken here? Well, I can do this a couple of ways. I could go back to the original x function here and consider what it will be in terms of its domain of t values. So substituting 0 and pi over 2 into this. So let's do that. So let's say when t equals 0, x is equal to 2 times cos of 2 times 0, which is just 2. When t is pi over 2, x equals 2 times cos of 2 times pi over 2, which gives minus 2. So x has to be between minus 2 and 2. So k is 2. The other way of answering that is just to look at the inside here, 18 minus 9x, and work from there. Right, part C of this question. Write down the range of f of x. Range is the y values. So let's look at the curve here. The curve value is like this. So the lowest the y value can possibly be is the y value here, and that's where y is equal to 0. The biggest the y value can be, well, the biggest the y value can be up here. What's the biggest that y can be there? Let's look at the y equation here. We've got 6 sine t. The biggest that sine t can be is when t is pi over 2. Because sine pi over 2 is 1. And that's the biggest it can be. If t was anything else between 0 and pi over 2, sine would be less than 1. So 6 times 1 is 6. So the biggest the y coordinate can be is 6. So we're saying that f of x has to be less than or equal to 6, but greater than or equal to 0.